we want to find the vertex, the fourth vertex of a rectangle. And first of all, what is a vertex? Let's just try my best to write a rectangle, pretend that these lines are straight, and let's pretend that each of these are 90 degrees. 90 degrees. A vertex is a point where two lines in the figure intersect each other. And that would be true in a rectangle. And suppose you had, I don't know, a pentagon, 1, 2, 3, 4, 5 sides. You know, this would be a vertex. This would be a vertex. And they give us 3 vertices of the rectangle. We have to find the fourth. Well, let's see. What we want to do is follow a certain pattern here. Let's take the point where x is 2 and y is 1. Suppose we wanted to move from there over to the point -1, -1. What would we do? We would go down from y is 1 to y is -1. So we would go down 2 spots and then over 3 spots from x is 2 to 1, 2, 3 to x is -1. So we've gone down 2 spots and over 3 slots. Now let's go to the point x is 6, y is -5 and follow the same pattern. So y is -5, we're going to go down 2 slots. So 1, 2. Now we're at -7 on the y-axis, which is right here. And x, we said we went 1, 2, 3 slots to the left. So if we went 1, 2, 3 slots to the left, 6 minus 3 is 3, we would be at the point where x is 3. I'll write that and then erase it just so as not to throw too much in the diagram here. So we would be at this point where x is 3 and y is -7. And that is the correct answer, 3, -7. Now you might wonder, well, how do I know for sure that that is a rectangle? Well, let's go back to the top here. You get from one point to another by saying we said down 2 and then 3 to the left. That's the same as up 2 and 3 to the right. Well, the rise over the run, that's the slope. The rise, the slope of that line, if I were to draw a line here, the slope is the rise over the run. It's 2 up and 3 over. Down here we have the same slope, 2 over 3. To get a rectangle, we want the slopes of those 2 line segments to be the same. And we also want the slopes of the other 2 sides of the diagram to be the same. So let's take a look here. To go from -1, 1 to 3, -7. Well, -1 to -7, so that's down 6. 1, 2, 3, 4, 5, 6. And x -1 to x3, that's over 4. So that slope, the rise over the run, it's actually a fall over a run. The fall over the run, right? So the slope for that would be, we said the fall is -6. The run was 4. So that can be simplified to -3 over 2. So let's see, I'll try my best to draw that line, something like that. And then how about this line segment over here? What's the slope of that? Well, to go from 2, 1 to 6, -5. The slope, in this case, the fall over the run, not the rise over the run, but the fall over the run, the slope was, we went from y is 1 to y is -5. So again, -6. And the run, +4, that also simplifies to -3 over 2. So that was more than you needed to know to solve the problem, but I think a very good review of slopes. And by the way, here's a fun fact. We had a slope of 2/3. So this was going up at a slope of 2/3. A slope of -3/2. So this is going down at slope of -3/2. You'll notice that one is the negative reciprocal of the other. So the reciprocal of 2/3 is what? You flip it over, it's 3/2. Then you put a negative sign. The negative reciprocal, if the line segments intersect and the slope of one is the negative reciprocal of the other one, that means this is a 90-degree angle. These are all 90-degree angles. So that's more than you needed to know to answer this question, but good to know for lines on the XY coordinate plane in general. If that made sense, I hope you'll click the like button, share it with your friends who are taking the ACT, subscribe to the channel, and if you have any thoughts at all you'd like to share, we'd love for you to write them in the comments section.